Mr. Umar and Mohammed, welcome to
Yes, thank you so much.
Welcome to our session, and Mr. Umar, welcome to our session.
Thank you, sir. Welcome.
So, where are you from?
I am from Pakistan.
Nice. Dr. Mohammed?
Umar Rashid.
Nice.
अस्सलाम वालेकुम रजा भाई, how are you?
वालेकुम सलाम, क्या हाल है आपके? ठीक है
जी अल्लाह का शुक्र, आप सुनाएं? ठीक है
यार, इसको कोई शुरू कर ले, पहले ही जा छोड़ दे हमारे।
हाँ जी, आपका कोई और भी पेपर है कि मेरे साथ?
क्या नाम है, मेरा लास्ट पे है, तो आई वांट टू रिक्वेस्ट डॉक्टर यासिर, if it's possible I can start at the first if the other participants are not available at the time.
यस, यासिर, इनका नेम क्या है पूरा? यासिर बकर, क्या नाम है? सही प्रोनाउंसिएशन नहीं पता। आपने कब से ज्वाइन की है? अभी ज्वाइन? रजा भाई, आपने कब से ज्वाइन की है?
किधर?
मैंने कहा आपने अभी ज्वाइन की है मीटिंग। पहले टाइम था आई थिंक 5:30 था, फिर मैंने जब ज्वाइन किया तो तब टाइम आया 7:30।
नहीं तो अभी ये स्टार्ट हो गई है मीटिंग की नहीं?
आई थिंक अभी टाइम है, अभी 7 मिनट रहते हैं।
ओके ओके। Dr. Yasir, can you hear us?
Yasir? Sorry?
What is your name pronunciation?
Yasir?
No, actually that username is the owner of the one of the member of the organizing committee. My exact name is Mehmet Emir Köksal.
Okay.
Where are you from?
Well, I live in Samsun, located in the Black Sea part of the at the coast of the Black Sea in Turkey. So I have been working for the Department of Mathematics in the 19 Mayıs University. It's a government university. I completed my BS on statistics, but I've completed my master, PhD, and postdoc study on applied mathematics. Then became associate professor 6 years ago.
Very nice.
Thank you.
Your profile is great, man.
Actually,
Yes.
Here Reza bhai bole.
Mr. Gospel, actually, I'm working on in the field of semantic technologies, knowledge management, and data integration.
Nice.
And I'm in this conference. I tried to present one of our case study about natural language processing on its models like that. So
Nice. So have you ever been to Turkey?
Uh, yes, I'm studying basically on student of masters in knowledge management.
Dr. Matev, welcome to our session.
Hello. My voice
Hi.
is my voice coming?
Right? Sure.
Okay, perfect.
How are you?
I'm fine. How about you?
Fine, thank you. So you are the 5th speaker.
Mhm.
The other friends are the last 2 speakers, but right now, 1st, 2nd, 3rd, and 4th speaker of the first 5 proceeding do not exist right now. And we may start from your presentation.
Okay.
After a few minutes.
Mhm.
Yes, sure. Yes, sure.
Okay, dear colleagues, welcome to 4th International Symposium on Multidisciplinary Studies and Innovative Technologies. So because of the coronavirus and its comments, so we have decided to organize this conference online, and I hope you will live away from the virus and get through this process without any trouble. My name is Mehmet Emir Köksal. I have been working on the departments of mathematics of 19 Mayıs University, located in the city of Samsun, at the Black Sea part of the Turkey. I completed my BS on statistics and master PhD and postdoc study on applied mathematics, and I got my associate professor degree 6 years ago, and study on differential equation, numerical analysis, linear system and control theory, and partial differential equations. So in this session, we have 8 presentations, but now we are only 4 persons. And the duration of every presentation is 15 minutes. And so the first speaker does not exist, and the second one does not exist also. The third one are absent. The fourth one. Okay, now I invite the Dr. Munjirina for his presentation because of the fact that the speaker of the first 3 presentations do not exist right here, as far as I see. Dr. Munjirina?
Yes, I am here. Can you hear me?
Yeah, we can hear you. So,
Okay. Hello, everyone. And I'm from Bangladesh, first of all. And if you guys have any complication about my speaking times, please let me know. And thank you. And this presentation.
okay. So you are host now, then you can share the screen of your computer to share your presentation.
Yes, sir. Can you give me a sec, please?
So you are host now, then you can share the screen of your presentation by pressing the green color at the bottom, you see. Share your screen. So we cannot see your presentation now.
Yes, sorry. Can you see me now?
Now we can see you. You can share your screen.
Okay. Sorry. Hello everybody, I am Munzirina Azum and I am from Bangladesh, and I am presenting for our conference paper as a speaker, and my paper name is Quality Assurance of Banking Sector Services through Multi-Criteria Decision Theory, and I am a speaker, already told it. And my co-author is Khadija Akhtar, Nafisa Haq, and MD Golam Rubiul Alam, who is our supervisor and assistant professor at Brack University, and I am also a Brack University student. This is the overview for our presentation and the paper also. First, we will talk about what is banking service quality, and our paper's objectives, related work methodology, research data set, result and discussion, conclusion, future work, and references. First of all, I want to say what is banking service quality. Bank sectors is a highly dependent person for now busiest because of the busiest work duration, and day by day the banking services is increasing, and because of using the technology the threat comes also increasing too. So that's why because of these things we develop a service security for, and also customer has right to choose which bank he want to use for banking service for security. And because of the betterment and the services, we will choose to develop HP Math framework for HP for making the decision which can help to control their services and their desired services and the quality and arrange which can control customers to arrange a sustain successfully, and also which is user friendly and easily talk about the user friendly and the service provider which bank is best for them and their desired. So that's all about banking survey and the objectives of our presentation of our paper. The objectives of this paper is we want to use AHP technique for banking for this banking service quality, and we were aimed to use AHP model to for assign ranking in each selected criteria and in total ranking. So we wanted to compare the standard of the service of various banks and observe diversity criteria. And now come up with related work. This is we talking this banking service in three sectors. Sorry, client benefit quality, entrance quality, item benefit quality. Client related, and we want to describe it. This is one kind of theory, and like many authors like for client benefit quality, Parsman et al. 1988 published that recent studies have shown that high level of customer service quality can exert a positive influence for customer satisfaction. Like we can use the product quality like repeat access, service quality for an abstract construct that definition and measurement obstacles. And another author like Cowling and Newman 1995 papers says that the server keyword instrument has been widely accessed for service quality and the various services organization for banking sectors like like the customer server keyword 5 quantity dimensions and the disparity between the customer's expectation and their participation. The perception was the highest reliability, responsiveness, empathy, this and the lowest tangibility, the sales like this client benefit quality. And the second one is entrance quality. Entrance quality, Stratier et al. Noted that one of the most important developments of the banking sector is increased while marketing wide for financial services. And Dixon author 1999 also argued about this field that the key for customers for banking sectors is the online services is not attraction of the internet itself, but the product offered to the customer. These are because of that 80% of the internet banking customers want to make a variety of financial transactions like online payment, bills, submitted bills, electrically paying. Because of that, it can be an issue for item benefit if the online transaction is going to be crossed or like hacked, that time it can be hampered for customers also who is dependent by banking service quality. That's all about our related work. Now come up with methodology. Although in first we talk about the HP methodology methods, and we used now we describe it on this methodology. We described our study in two ways: analytical hierarchy process and research methodology. And analytical hierarchy procedures (HP) is pairwise comparison for system for making decisions. It's a qualitative and quantitative research for making discovery, review, documentation, the element of the final decision, and the structure. It's a structural program for making decisions where customer can easily choose their services and the quality of the banks. And next topic is research methodology. Research methodology, we will describe it in 5 phases. First phase is establish the factors and sub-criteria. We will talk on data set about these factors and sub-criteria. Factors is for our like client benefit quality, entrance quality, and item benefited quality. And based on that, we will provide some sub-criteria about it. And structuring a hierarchy mode is like considering the factors for service quality analysis in bank for using a hierarchy mode or model, and the model for which can easily client define for services. And third one is measurement and collection knowledge. We got a data set for using the excess, the relative weight against the set of vital and sub-factors. And fourth one is crucial, the normalized weights. Global weights, factors, and sub-factors were conjointly using the pairwise conventions, and that's why that is ensures that the priority weight and the relative importance for individual factors and sub-factors comes successively, and the weight comes much relative for using this and normalized, and finding the answer for to the downside by dividing the matter of into hierarchical mode is like we use 5-point scale here on data set. We will talk about this phase later on data set time. We will using 5-point of the scale. Scale is outstanding, great, average, 4, or fail. So based on that, we will and their value, we will got a value from our data set, and the scale is used for disciplinary action here. And data set is we got a data set from or the which is discuss the efficiency of banking sector services. That's why we will and the paper name is Evaluation of Services Quality in Banking using the typical case of Indian banks. And we thought that our experiment we can use our experiment we can use this method or use this data, sorry, for our experiment. And on data set time, we got 300 questionnaires were randomly distributed for some specific branches of the bank. Well, basically we compared it two banks, and the procedure for resulted is 165 completed questionnaires, 55% unusable response rate. The questionnaire for customers is like customers profile, name, age, gender, and qualification. 73% was male and 27% were female. and the maximum the range is comes 21 to 67 years, and the one we sample it or responses in two groups. One group is above 40, one group is above below 40. Most of the person is very qualitatively and working the understanding the banking security services much better than much better. So I already told it the subcategory here. Like that for banking service quality we got a three criteria: item benefit, client benefit quality, entrance quality. And item benefit quality sub criteria is account facility, investment, advisory services, bill payments, credit facilities. And client benefit quality is reliability, responsiveness, competence, courtesy, excesses, communication, etc. And entrance quality is contents, accuracy, easy to use, timeliness, and authentic security. And based on this, all over the criteria is called the service quality. Next is result and discussion. I already told it on related work on phase 5 that we got 5 point of scale here: outstanding rate, average, fair, 4, and their required weights is outstanding is 0.513, rate is 0.216, average is 0.129, fair is 0.063, 4 is 0.034. First we will use local weights first, that from survey, and for each criteria on item benefit quality. After the average, we got item benefit quality is local weight, and when we multiply two local weight criteria and sub criteria, each sub criteria's local weight, that time we got global weight, which is and after finding the global weight, we will each criteria's global weight we will multiply it with ranking, which we got from survey data set. And after that we will compare it on we will make sum and compare it uh, with rank is best. And this is the steps for
Okay.
how we get total score.
Sorry for breaking. You have 1 minute as the remaining time. Okay, Dr. Manjrina,
Yes, sir.
just you have 1 minute as the remaining time.
Okay, sorry,
Okay.
sir. I don't understand. And this is the total resulting we will got, and this is the graph you can see. And in conclusion, we can finally we come up as a conclusion. The first of all, we want to achieve the objectives of AHP for banking service quality, and we will want to say that bank B is much better than bank A, and we, in spite of the stages, are performed consecutively. The choice producer can go back to present to preceding the sections to able the form of many changes and one or more prominent degree within the choice. And the advantages of AHP also we want to use here, and how to keep how to AHP to advancement and the chain of the command and the pairwise comparisons. Next, come up with the future work. The future work is our, like, we want to use HP here, but we want to use HP's updated framework, which is a sensitivity analysis, and which can make more prioritized weights. And sensitivity analysis is a software platform like a user can easily say what is the differences to the previous and now. And the expert software, the methodology, experts says that the methodology that will allow the use of the original judgmental, and we will try to represent it, and also the importance of citation. That's all the analysis, and this is the references of our paper. Thank you. If you guys have any questions, feel free to ask.
Thank you very much for your presentation.
Thank
Is
you.
there any question, remark, or comments? So everything is clear and obvious. Thank you for your great presentation. Let's applaud him. Okay,
Thank you.
thank you for your presentation. Could you please make me the host again, please? So right now you are host.
Yes, sir. Hosted now?
Yes, yes.
Okay.
So press over my name, then right click with mouse, then you can see that how to make me host. Dr. Munjirina,
Yes, sir.
just from the participant link, participants press over my username, then right click, then make me host again. Okay.
Yes, sir. Yes, sir, I will.
Okay. Okay, thank you. Okay, welcome to Hamidullah, Dr. Hamidullah.
Thank you, thank you.
So,
You're welcome.
so the speaker of the first and second, the third presentation does not exist, then the speaker of the fourth presentation has just completed her presentation.
Okay.
The next presentation, I mean the speaker of the fifth presentation is Dr. Matthew, and the title of his talk is on the preliminary design of a novel kinematic foreign model for prospination motion. Dr. Matthew?
Yeah, I can hear you. I hope everyone can hear me.
Okay. So can you share your screen now?
Yes.
Okay.
Okay.
The duration of presentation is 15 minutes.
So I'm starting then. Okay, so hello everyone. Today I'm going to talk about our study, which is the preliminary design of a novel kinematic forearm model for prospination motion. I'm Matthew Aras. I'm the currently master student in Middle East Technical University Northern Cyprus campus mechanical engineering program, and I'm working in this study under the supervision of Dr. Besat Bahadır Kentel, who is from the Atılım University's mechanical engineering department. So here's our outline for today, and at the end of the presentation, if you have any questions, I'll gladly answer all. So first of all, I would like to start with the basics biomechanics of the forearm. With our forearm, we can do two kinds of motions. One of them is flexion extension, which is shown in the left side. And the other one is pronation supination, which is shown in the right side. And the pronation supination motion is our concern in this study. So Our motivation in this study is understanding the motion of the forearm in much clearer way because it plays very important role in many daily activities and many research areas such as sports science researches, clinical researches, and robotics and prosthetic systems. In the literature, there are different simulation-based models, but in general, those models are considering the forearm as a single element, which is useful for the simplified forearm motion analysis. However, those models are not giving realistic results, and they're not insufficient to explain the actual forearm motion. So our aim is in this study, our aim is to develop a kinematic forearm model to estimate the presupination axis of the forearm without increasing the computational load. And we built a realistic novel two-segment closed-loop forearm model, which includes moving presupination axis rather than a fixed one. And our 3D kinematic model includes moving rotational axis. In short, we named it as MRI for presupination motion. So when we come up to the literature survey, we found that the previous studies define this complex presupination motion as a relative motion of the radius around the ulna bone. And they also found that the rotation axis is not constant with the longitudinal axis of the forearm. And they define the rotation axis, which passes from the radius at the proximal end, which is this side, and from the ulna head at the distal end of the forearm. And also those studies try to define the presupination axis in different ways. Some of them try to fit whole motion onto a single axis, and more recent studies try to fit the motion on variable axes according to their according to the different spination angles. So when we come up to the previous kinematic models, they try to define the presupination motion with the different combinations of the mechanical joints. With the presupination motion can be expressed from the radio-ulnar joint. And as you can see, the previous kinematic models try to define the presupination angle with the different joint combinations, mechanical joint combinations at the proximal end and the distal end of the kinematic model. So in our study, we try to build a generic forearm model by using the 58th percentile male anthropometric data. And our model parameters are shown in the table 1, which is placed at the left side. And the difference of our kinematic model is that our new kinematic chain allows the moving rotation axis as a link inside the mechanical model. So if you look at the 2D scheme and the 3D scheme of our kinematic model, we can see that in the yellow link, the link 1 is the elbow connection between the ulna and radius. Link 2, which is the green link, represents the ulna bone. And link 3, which is the blue one, represents the radius segment that we designed as included. We designed it to include the radius bone, which is represented with the R5 vector, and the MRI inside of it, which is represented with the R4 vector. And our mechanism is a 2 degree of freedom mechanism, and our degree of freedoms in this mechanism are the presupination angle, which is theta, and the location of the MRI at the distal end, which is represented with the S2 displacement. So we did kinematic analysis to find the joint variables and the orientation of the distal radial. The first step that we did is by using the equation 1, we wrote the loop closure equation by using the successive rotations and the translations, which shown in the equation 1, and by using the joint input parameters, which shown in table 2, we did the kinematic analysis. By using the inverse kinematic analysis, we found the joint variables by knowing the location of the MRI, and we use we, we use the forward kinematics to find the orientation of distal radius head by knowing the prospination angles and the joint variables that we found from the inverse kinematic analysis. When we come up to our results and discussion part, and figure 2, we want to show you the motion of the location of the radius at from the different planes. And also figure 2a, we want to compare the rotation around the moving rotation axis and the fixed rotation axis. As you can see, the blue line shows rotation around the moving rotation axis, and the red one shows the rotation of the radius head around the fixed rotation axis. So for 2b and 2a, and also 2a, 2b, and 2c, we can see that rotation around, when we rotate the radius around the moving rotation axis, we observe the symmetrical pattern for the symmetrical pattern in 3 different planes. And when we compare the moving rotation axis and the fixed rotation axis, we saw that there is a huge difference at the pronation pose. And also from the previous studies, the previous studies found that the range of motion at the spination pose, anatomically, the range of motion of the spination pose is much greater than the range of motion of the pronation pose. However, when we look at the rotation around the fixed axis, we saw that the range of motion of the pronation pose is greater than the range of motion of the spination pose, and this causes an unrealistic forearm motion. And this means that when we rotate the forearm around the fixed axis, we're going to obtain unrealistic hand motion. So, and when we look at the moving rotation axis, our rotation is observed in the elliptical pattern, and which is consistent with the previous studies. And also, as you can see, the range of motion of the pronation is not greater than the range of motion of the spination, and which is also consistent with the previous studies. And when we look at the joint variables, as you can see, phi1 and phi2 are observed really small. The reason for that is, since we locate the MRI slot at the distal end in horizontally, and the variation of the MRI at the slot is almost 10 millimeters, compared to the linked lengths, the slot length is really small. And because of this, we were expecting to see really small changes at the proximal end, which is also shown in the figure 3a and 3b. And in the figure 4, we show you the axial displacement of the ulna head with the axial displacement of the ulna at the humero-ulnar joint with our kinematic model. And when we compare this result with our previous studies, we found that our results came a little bit smaller than what they found, and we found in the different pattern. So which shows that we need to also work on the elbow joint for the further study. And when we come up to the 3D motion of the radius segment, as you can see in the figure 5a, there's different planes for the different prospination angles. And from the green dot shows the neutral pose of the radius. Red one shows the maximum spination pose, and the blue one shows the maximum pronation pose. And from darker plane to lighter plane, the radius segment goes from to neutral pose to spination and neutral pose to pronation. So when we compare the motion of our 3D our radius segment with the previous studies, we found that with our model we can find the consistent results with the studies that fix the ulna for the rotation to observe the rotation of the radius. And this shows that our model can give consistent results for when we fix the ulna. So in conclusion, the goal of the proposed model is to obtain the realistic forearm motion by using the moving rotation axis as the precipitation rotation axis parameters. And by using these parameters, we can easily adjust the proposed model for the subject-specific studies. And this shows that our model is also applicable for the subject-specific studies, which is defined in the TIES article, that is the 16th article in our reference list. And when we checked our results, we saw that our proposed model gave consistent results with the previous studies, when we compared with the references that I gave here. And when we compared the moving rotation axis and the fixed rotation axis cases, we found that the rotation around the moving rotation axis is consistent with the previous studies. However, rotation around the fixed axis is not. From the ulnar displacement, we also found that we need to, the further investigations are required for the elbow joint. For the further improvements, we may include a second slot at the proximal radius head, and we may generate an optimum slot path for the MRI at the distal head. Also, the location of the wrist joint center and the orientation of the hand will be obtained from the motion analysis, and we can use this data that we obtain from the motion analysis to assess the accuracy of the model. And also we may test our model to see the capability of the model at the different motion analysis, not only the pure pronation supination, but in the daily activity tasks. And at the final stage, we hope that the model might help the clinical investigations, the injury prevention and the sport analysis, and the development of the prosthetic systems. So here's our reference list. If you're interested with the topic, you may search them. There are really good informations in those articles. So if you have any questions, I'm glad to answer all. Thank you for your attention.
Thank you for your presentation. Is there any question, comments, remark? So thanks again for your presentation.
Thank you.
Are the speakers of the first three presentations present or absent? No. Dr. Hamidullah, your name is Turkmen or Nazari?
My name is Hamidullah Nazari. My surname is Nazari.
So your surname appears as a Turkmen, but
my nickname is Turkmen. I use my nickname.
Nickname. Okay,
Yeah.
okay.
Yeah.
Now, Hamidullah Nazari is the speaker of the third presentation from the last. So the duration of the presentation, 15 minutes. Okay.
Okay. Can I
Please
share?
pay attention to the duration of the presentation. Okay, the title of his talk is A Deep Learning Model for Image Retrain Getting Level Detection.
Yes.
You can start.
Nice. Okay. Hello everyone. My name is Hamidullah Nazari. I am a student in Sakarya University in the Faculty of Computer and Information Engineering, and I'm a master's student. Today I'm going to present about the deep learning model for image retargeting label detection. I have summarized my presentation into 5 major slides plus reference, and here we go. The first is introduction. The second is what is the sim carving. The third is proposed our CNN model. The fourth is result, and the last one is conclusion. detection of image retargeting based on SIM carving, which is one of the widely used content-aware image resizing algorithm, is of importance in image forensic. In this study, we developed a deep learning model that performs multi-class classification for the detection image retargeting labels. What's the SIM carving? SIM carving algorithm, or content-aware image retargeting algorithm, is developed by Abidin and Sharma in 2007. The logic of this algorithm creates a line. It's called SIM. These are from specific pixel by calculating the pixel in the image with the low energy without any cropping and scaling, which is called the energy functions. These are. This pixel lines is performed horizontally or vertically by finding a pixel with a small or low energy from each lines, deleting a pixel if it is to be reduced, and adding it if the image is to be enlarged. Traditional SIM carving detectors usually have output SIM carved or not SIM carved, but in our proposed model gives an insights into the degrees of SIM carving labels, like a not SIM carved or original image, raw image, 10% applied SIM carved, 20% SIM card applied image, and 40 applied SIM card image. We detected this percentage of images. Our proposed convolution neural model is has in the it has a 5 convolution layers, 5 max polling, and 2 fully connected layers. The number of kernels for each convolution layer are 32, 64, 64, 128, and 256 respectively. All convolution layers have 3 times 3 kernels. Input image size is set to 500 width dimension and the 500 height dimension, and the RGB 3 channel. All max polling layers have a full size of 3 times 2. It's the shape of our model, our developed model. Following the flattened layer, in the flattened layer, the first dense layer is designated as a 512 nodes. The number of outputs in the last layer, whereas softmax function is used for multi-class classification, is set to 4. These are 0, 10, and 20, 40. The range of each output varies between 0 and 1 as an estimate of input image SIM card label. In this study, we built our deep learning models by using Python programming language and Keras library. In training our models, we use ImageNet dataset in the dimension of all images 500 width, 500 height, and smaller images. Training folder contained 30,000 raw image, and validation folders contains 10,000 raw images. Inside train and validation folder have 4 image folder for 4 classes. Vertical SIM card was applied to raw image and at the scaling rate of 10%, 20%, and 40%. Hence, there are total 4 times 30,000 equal to 120,000 image in the training folder. And the validation folder has 4 times 10,000 equal 40,000 images has. The validation accuracy about the 84%, which is a good value for such a kind of these problems. For evaluating our CNN model, we use confusion matrix and other matrix like a precision, recall, if-first score, and true false, negative false. We use these matrix. The conclusion: a different model based on CNN model for SIM carving detection was developed. In addition to SIM carving detection, developed model has also multiple outputs to determine SIM carving levels for SIM reduction. According to the result, our trained model has 84% validation accuracy. Our analysis of the model was performed by testing model on the image and showing the result of confusion, precision, recalls, matrix in details, as well as accuracy values. This is the reference. Thank you for listening me.
Thank you for your presentation. Is there any question, remark, or comments? Okay, thanks again for your presentation.
You are welcome.
Okay. The next presentation will be given by Dr. Umar Rashid. And the title of his talk is Emotion Detection of Contextual Text Using Deep Learning. Dr. Umar?
Yes, sir, I am here.
Okay.
Please make me host.
Okay, you can
I
start.
will share screen.
You can share and you can start. Okay.
Is it visible for all?
Right.
Yes. Can I start?
Sure.
Yes. Bismillahirrahmanirrahim. My title is Emotion Detection of Contextual Text Using Deep Learning. And my name is Umar Rashid, and here is my co-author. So I am start from my outline. First of all, I talking about abstract, then introduction, then literature review, proposed approach, evaluation and experiments, and results, conclusion and references. So first of all, abstract. In recent years, the data in the form of text is created in very huge amount in day-to-day conversation on social media. We have WhatsApp, Facebook, Twitter, Instagram, a lot of data here, and we need to improve and we need to detect the emotions from text. So we need a naive approach to analyze and summarize data to extract meaningful information. Textual dialogue is given in contextual emotion detection. So we have to recognize user emotion, either it is happy and sad, angry, or others. So this paper describe about ambient system which detect emotion from textual dialogues, which is contextual text. So this system used to long short-term memory model based on deep learning to detect the emotion like happy, sad, angry in contextual conversation. The main input to the system is a combination of word to vec and documents to embeddings. The output results are substantial changes in F score over the model baseline immune system score is 0.718. So this is the abstract introduction. What we use the model name is LSTM in deep learning. So here is some introduction about textual data is created too much in the form of conversation like Messenger, WhatsApp, Twitter, and photo reviews. So it is very difficult to analyze this type of textual data. So to get emotions from conversation, deep learning model or natural language processing used for that. So example of 3-turn conversation is, for example, a female said, I am feeling low. So why? Something is seriously wrong with my life. So it detect when we saw this chat, it is sad. So it is very important to detect this textual to get emotions from these texts. So that's why we use deep learning model, NLP model. So so in my literature we have these parts: emotion understandings. So what are emotions? To understand emotion, it is very necessary. The emotion expressed by human being is different way, such as writing, speech, gesture, and body language. And so we need an appropriate model to categorize these emotions, as we can evaluate personal blogs or tweets for detection of species, purpose of talk, or hidden emotion of the person in the text or speech. So the first theory of emotion detection was proposed by in 1872, in which humans and animals express different emotion with a different ways. Later on, the emotion described as brain mechanism in 1984, which give the concept of neural networks. Evolution theory said that the emotion varies with the passage of time. So to detect the emotion like happy and angry, novel deep learning approach used it to combine the both sentiment techniques to explore the real world conversation dataset for getting better results on emotion detection. So in the domain of text, speech, and images, deep neural network approach considered to accomplish the task successfully. So an LSTM and neural network algorithm are more operative and effective as stated there. So second is model for emotion detection. What are the models we use to detect the emotions? So the model is a structured way to describe an emotion from the text. To categorize emotion, we need to define the emotion types. In this work, we define our 4 types of emotion, which one is sad, happy, angry, and others. The most recent work on emotion, in which the researchers used an idea of synthetic rules, semantic knowledge. The author used voice tone and frequency of audio as input to analyze emotions. So in this work we used expression and gesture from videos and extract emotion, but as our goal was to get emotion from text. So we concentrated on the model that can perform well to understand the text. So third one is method for emotion detection through text. Most of the emotion are expressed in the form of text by different people in different ways on social medias. Following methods are introduced to analyze these emotions from text data. Recurring neural network described for classification of emotion through tracking of individual conversational state. And fourth one is keyword based method. Keyword extraction was the most basic and straightforward approach by part of speech tagging. The keyword is extracted and matched with a word identified and emotional words. And fifth one is machine learning and then hybrid method. In machine learning, we have for the motion detection, the supervised and unsupervised machine learning approach can be used. In supervised learning, we have a complete labeled data set, whereas in supervised, we have unlabeled data set. The data set, 1/3 was used for training and remaining was used for testing. So in hybrid method, uh, we try to combine all the methods mentioned above to achieve better accuracy. So recent work in done 2018, which was done on the same data set which we are working on, we use LSTM model. They claim that emotion extraction for text was a challenging process in the absence of facial expression and voice. So, so approach comparison, here is a different models like a LSTM model and LDA SVM support vector machine, EMONets SVM support vector machine. So these embeddings are used and to detect the emotion type: happy, sad, angry, happy, sad, angry, and fear, happy, angry, sad, and disgusting, joy, anger, fear, sad. So this is a F1 score on different researcher apply these approaches and getting results. So here is some researcher find brain emotion classification of Chinese microbiome based on graph convolution by Lia, Y. Zhang, and their co-authors, 2020. Emotion mining using semantic similarity in natural language processing concepts, methodology, tools, application by Jan or Khan, and identification of suitable biomarker for stress emotion. So these are the scientists who have the contribution about to detect the emotions. And next our is proposed approach. So we in this diagram you see your right side we have an input data. So we collect the data set of conversation data. In this we have applied different techniques, pre-processing techniques, or remove extra spaces, remove invalid characters, resolve characters. So our proposed pro use the LSTM bidirectional word embedding and notated cops. First step is pre-processing TG, which apply on the input data. So, in which we remove the extra spaces, invalid characters, resolve the character encoding and correction of spelling done. After the pre-processing, adding words for interpretive or labels in annotated cops and word embedding techniques apply on the input data. So mapping the dataset through vocabulary for getting real number of words. LSTM apply for training and dataset, which filter the dataset and detect the emotion of happy, sad, angry from the dataset. So input and pre-processing techniques in which we make sure our dataset clean and good and effective for our training model. The training dataset have been tokenized for transforming the sentence into words and converting all uppercase letters into lowercase. So we also include stemming the word used NLTK stammer, which is the library of NLTK, and remove of extraneous white space. We also convert multiple instance sign to single instance. Okay, show to while construction. These are the stemmings words. So spelling correction. Then we have word embeddings. We have to give user alternance to a neural network, and we have to obtain word embedding for each word in the input sequence. So for this, we try to use the word to vec, glob, and fast text model for reconstruction of embedding words. So we train a simple LSTM model by using each of these above mentioned embeddings to test the effectiveness of these embeddings. So we validate this using 10-fold cross validation to ascertain the effectiveness of various embeddings. Finally, we used a glove tweeter, which is our dataset, 1.2 GB embeddings model because it performed better than other. So at the end, we train our model. For model training, first of all, we split our data in a ratio of 9:1 and divide it into two sets. One of training data set and second is validation data set. On the training set, we train our model, and with validation set, we tune the hyperparameter and we use grid CV search for hyperparameter. So we choose grid CV search because it can include more parameters for analysis without affecting the overall performance. So we try different optimizer like adaptive movement, estimation algorithms, and different algorithms we used. After hyperparameter tuning, we decide to use category softmax using entropy as loss function, as admax as our learner function. So we obtain the learning ratio of 0.003 and 200, which is optimal. And then our evaluation and experiments. Next slide. Evaluation and experiments in which we have a data description. The data set we use to provide by SMAble 2019. The data set consists of 15,000 tweeters, conversational PST, uh, conversation, and it's put together. The last class label we use the expert opinion from judges. We have the third sentence of the conversation of the context of past two sentences to judges. Each conversation has shown to 5 judges of high quality judgment who emotion classify, we take the majority votes. So then we have to shape of data set in which we describe the shape turn one ID having an identical number to identify each training sample. We train our sample, and then evaluation and matrices, in which we calculate the average scored F1 done by equation, and then we baseline approach use. Baseline approach is provided by SML for data pre-processing. They use Keras pre-processing technique, tokenization, hashing tricks. So these are the comparisons results obtained from different embedding using by LSTM network. So approaches we use word2vec and FastX and Glove. Here we have a F1 score 64.44 and SAT score 74.71, Angry score 59.28, and we have getting the average values of these different approaches. As we notice that the Glove F1 score which we use in our model is more greater than word2vec and fast text. So these are the two comparison of our system and baseline, where we have a accuracy. Ambient when baseline F1 score, and blue color shows angry, and green color shows sadness, and red color show happy. So we tried to comparison these two algorithm, ambient with baseline, and these are their F1 score shown in this graph. So comparison of our approach with baseline approach, we comparison with precision, recall, and F1. So our aiming system have more effective than baseline. So here is the conclusion. In this paper, we propose our method for detection and classification of motion from a 3-turn conversation. So our method involved building a word embedding from pre-trained embeddings, Glove Twitter 27 byte. We also contribute to pre-processing of data by using different techniques, normalization of data by removing repeated character spellings and correction, etc. We also applied stop words removal, but it reduced the accuracy, from which we analyzed that stop word removal technique is not efficient for a contextual task. Then we use the most recent stage by long short-term memory on that problem. We took word embeddings as input and predicted motion. To make it more optimized for our selected dataset, we also perform hyperparameter tuning and choose the best parameter on which our model perform well on our data. Through these techniques, we achieve the F1 score is 0.7189, which is greater than our comparison models like baseline, which is higher as compared to other models. So as a future work, we have planned to extend hybrid approach by using emotion lexicon, emotion handling, and other method like semantic. So here are the references which is helpful for further research, and that's it. Thanks for your attention.
Thank you for your presentation. Is there any question, remark, or comments? Let's applause Dr. Umar for his presentation. Okay, last speaker is Dr. Mohammed Raza Naqvi. The title of his talk is Need for Computational and Physical Linguistic Models in Natural Language Processing for Web Documents. Dr. Mohammed?
Yes, please. Kindly allow me to share the screen.
Okay, yes. Just seconds. Dr. Umar, could you please stop to share your screen?
उमर स्क्रीन बंद कर दो.
Okay. You can start and share your screen. Okay.
Can you see now?
You have started screen sharing. Wait seconds. Yes, right now, yes. Okay, you can start.
Thank you. Today my topic of the presentation is need of computational and psycholinguistic models in natural language processing for web documents. My name is Syed Raza Naqvi and other authors are Syed Khurramshad, Muhammad Wasim Iqbal, Muhammad Ahmed and Babar Ayub Khan. And first of all, I would like to discuss about natural language processing. Natural language processing is an argument that provokes territory of figural manner of motorized scrutiny and deception of human language. Research in it unfolds from the term of punch card till the aid of intelligent examination engines which take less than a second to figure out millions of web pages and detailed documents. In the web pieces of the evidence, an end user produce content to have formally simulated text, the obligation of advantages and driving it decisive. Consequently, the web is treated as a far more source of evidence brought about extensive and considering the on content formulation, it has influenced the information resource. However, special developments in the NLP probe to perceive the scope of machine learning in modern era to avoid ramification of adverse instructions. Next, I will start a little introduction. As you know, the the knowledge is always unstructured or semi-structured is very difficult task to understand. In the age of internet, people have access to online repositories as text and web documents. People spend less time on the entire document rather than on the desired information they have got. So to encounter these automated text summarization and given separate the summary of the text help people to decide whether the document is relevant to their desired result or not. The situation required comprehensive research in area of automatic text summarization. Um, as social networks come into the web until the source of data has been accepted, the approach of such size and empowered communal sharing and data virtually with all our internet users and economic beneficial and effective means. All the amount of data is non-analytic, which having sense of that it mentions statistics and being observed for humanitarian sympathetic and thus not whereas overall the NLP desired very enormous data to be investigated, so it is difficult for the user to go ahead without scrutinizing the web as markable origin of requirement. Moreover, some consideration have validated the versatility of web-driven facts of word sense, transcription, briefing, and language curve. We have studied some models which we see that at this time the user can report and accept the instruction to process natural language processing by data from the web document. For this purpose, the first time the conjunctive layer are being treated in mechanism. Leddy and the Feldman advocated in 1998 and in 1999 the natural language may be measured. These concluded that the general adoption of multi-levels of people operate in good implication from text to an utter languages normally. Mehdi proposed a model that extracts sentences from text using features as words and phrases. The project model where the sentences from a document as a function of high frequency words ignoring. Luna had described a paradigm based on key phrases. This information is required to estimate the textual sub data in web pages. Also, when it comes to an objection of making sensor and autonomy effectiveness is still very depressed. The current ultimate of extant quick fixes are untroubled. The occupying the deception of the performance concludes still on word construction regularity. Such algorithms can grow what can detect, have very unwise competence. After all, it has been outlet since the start of evolution of natural language processing in the field of science. In most of the natural language processing researchers, the researchers focus on scientific analysis. The reason they reflect syntax as our constant and categorically construction in syntax-driven processing. Next, we discuss how the natural language the problem we have identified by reviewing the our research methodology by doing the literature review. the need and problems of semantics in natural language processing were clear, but the blueprint chosen by the researcher comprised the synthetic research essentially and formally approaching the other complications of compassionate of machines. Meantime, a few analysts on semantic advanced that they were reasoning and semantic driven access is enough better and higher rejection. Later, it was exposed that we need awareness and undoubtedly question answering. Till then, research on semantic encounter not being able to adopt in impression to the human conduct. Researchers are working on this. So we have discussed some ongoing precedents that how a natural language processing is working. So there is lexical analysis, homonical analysis, polysemic analysis, syntactic analysis, and syntactic analysis is divided in two parts, which is one is attachment level and one is coordination level. One is semantic level, which has scope level and anthoric level, and the other one are pragmatic and differential. Use studies which can get the reference of. So there is a figure of lexical and syntactic level analysis cycle where user can add the input, and the lexical analysis read characters and send to the lexical syntax analyzer which is in the token. So syntactic analyzer can ask to the lexical analyzer for the token and push back the extra characters. This is the ongoing precedent in the natural language processing, which start from lexical analysis, then syntactic analysis, semantic analysis, discourse integration, and pragmatic analysis. And the most common used natural language processing applications for semantic search in web documents are Cortana, which is used in the Windows, and Siri as in the iPhone, and the most used application is Google Assistant, which we call Hello. Now we conduct a case study to prove that semantic and computational assistant applied on natural language processing and how it operates and perform on user query which is in natural language processing. And we choose Google Assistant Hello to perform our case study because it's the most used uh, application as per for the searching of web documents using natural language processing. So here we can see the one person is try to buy a car. So he asked what I can do for you, and he asked that my friend's name is Ahmed. So the system after analyzing say that okay, I will remember that, and the next figure uh, we ask that delete all my chat history of Google Assistant. So it's not working. In the first two pictures, give a proper answer on the initial statement as we query and command to remember the name out of our friend and check whether he owns the car or not. And in the next two figures, like this one, when you will ask for the referential task here, and you will ask for referential, it will take you to the another result which is not relating to the existing factor. So we can say in the figure 5 and 6 syntactical sentence making compiler task which is perfectly judged by the NLP processor. But if you see in the next two figures, when it's related to an own sentence, it just came to know that. So in above all these figures, the ability of Google Assistant to perform different kinds of natural language processing based tasks so that we can find how much efficient it is to find online text that contains the psychological behavior using the Google Psychological Natural Language Text Analysis model. The above case study shows there is still need of computational and psycho-linguistic models in natural language processing for web document searching. So the conclusion is web, which is considerable cause of a data over the internet, has some present document that can be refined. Other partly present is not document or abstract, which desirable for to a few faction reason or some alike, we can't discount data sense of this explosive chunk of data to object, and we previously demand enough data to be handled under natural language processing for directed to the machine learning. So in paper, we confirm the natural language processing deficiency as far as text content semantic analysis is needed. It is mostly worked upon, but on semantic and relations for which we need computational models to perceive and behavior of nature. In few years, we will hopefully be able to make our algorithm that will relate the talk with this closer integration. These are the references which we used for this work, and thank you so much for the time. Any questions? If
Thank you for your presentation. Is there any question, remark, or comments? So let's plus Dr. Mohammed again. Okay.
thank you so much.
Thank you everyone and your participations. I hope to meet in another international conference without virus. Nice to meet you again. Okay, I will end up the session.
Sure.
And every participant has completed their presentations. Okay, nice to meet you again.
Thank you so much. Okay.
Okay, thank you.